Hey YouTube, it's Dimitri, and today we're going to talk about one of the hardest questions that people ask me, and one that's very, very common. And the question is Dimitri, which degree should I get? Okay, so this is a really challenging question because there's so many different things that contribute to the answer that the degree I tell you to get is going to be dependent on what your goals are and who you are as a person. So let's just dive on into some of the details here, and we'll talk about the pros and the cons and what to look for in degrees. But in general, let's just dive on in. Okay, so to start off with, the number one question you should be asking yourself before you ask anyone else, because I can't answer this for you, is what do you want to do for a career? And the second question is, why do you want to do that career? Okay, I think these are both crucial questions to ask. So the reason I'm asking this or kind of stating this is I'll have somebody reach out to me and they'll say, Dimitri, I want to be like a portfolio manager and I want to do all this investing and I want to beat the markets and I want to be really smart, but I want to do all this investing stuff. So I should get a financial engineering degree, right? And I'm like, it depends, right? Like, for example, are you wanting to be a traditional finance manager? Do you have an undergrad degree in finance? If you do, you're probably going to want to go the traditional finance route because you don't have the background or the education to do quantitative finance at that point. Switching again now from business, so finance, to quantitative finance is extremely challenging, and we'll talk about that a little bit later in the video. But in general, the question is what degree should I get? Needs to be, what is your end goal? If your end goal is just to be a portfolio manager, right, then the question needs to be, well, what type of portfolio manager, right? You need to define your end goal as best as possible. So do you want to be a traditional finance portfolio manager? Do you want to be a quantitative finance portfolio manager? Do you want to work with like general kind of laid back and active investing? So retirements, 401ks, pension management. Do you want to do that? Or do you want to work at a hedge fund where you're doing more or less proprietary trading for the firm internally? Like there's all these questions and you need to define the goal as clear as possible before you even get going on which degree you want to look at, because your goal is going to define what you should be doing. Okay. The second one is a little more challenging, which is why do you want to do this? So the worst answer I get consistently is, Dimitri, I want to do this because I want to make a lot of money. Okay, well, I mean, define a lot of money, and B, I can tell you, if you're in it for the money, you're not going to make a lot of money. I know it sounds kind of counterintuitive, but those in quantitative finance, for example, that make a lot of money, they're in it because they love math and stats and computer science, right? That's why they're succeeding. It's not because they're trying to make a lot of money and they just want to make a lot of money. That's not how it works. If you enjoy finance, for example, and you go on the finance side, same thing. There are a lot of careers, guys, that aren't even related to quantitative finance, data science, actuarial sciences, any of these fields. You could go out, for example, and be a professional athlete. That makes a whole lot more money in general than being a quant or being a data scientist. You could be a software engineer, which again, we're going to talk about a little bit, but a software engineer is going to need a completely different degree than a data scientist, a statistician, a mathematician. They're all different degrees. So if you're looking to make money, I think it's a pretty poor decision. Like I get like when you make the decision on a degree, and I've mentioned this in the past, look at the return. What are you investing in? Time and money for the degree. What is going to be the expected payout from the degree? So the average compensation. Do not look at the maximum and say, I'm a really smart guy or a really smart gal here, and I'm going to make that $10 million. Because I'm going to tell you the chance of you doing that is very slim, and it's a really poor investment decision if you're looking at the maximum instead of looking at the average. Okay, so now looking at the degrees specifically here. So I'm going to cover this from different angles. This doesn't just cover quantitative finance or financial engineering or data science or machine learning or any of this. We're going to talk about these a little bit and what degrees are good for different things. But the big takeaway I hope you get from this video is every degree is valuable in some shape or form. Okay, there's no degree out there that is like dominant to all other degrees. Like there's not a best degree to get, okay? And for someone that works in quantitative finance, for example, I see tons of people in my industry that come from all these different backgrounds. So I can tell you what's the most common route, but I can't tell you, for example, like this is the only route. Like you could come in different angles. I have different colleagues with PhDs, for example, in fields that are science related, but have no relations to finance or analytics or any of that stuff. And they're still working in the industry because they either have a master's plus the PhD, and the PhD actually adds research value. So again, there's all these different things to look at. But in general, there are multiple paths to get to where you want to go, and nothing in life is going to be linear. Okay, now that being said, for undergraduate degrees, I think, again, defining the goal is important here. So if you want to work in quantitative finance, there is a threshold that you need at minimum a master's degree. A PhD is actually preferred over a master's. So you need to start weighing your options and thinking about that long term. Like, I need to get a master's or a PhD. Which one should I get? How much time do I want to invest in it? What do I think the expected payoff is? And what is the fail rate? Because a lot of times you might go get the degree, even a PhD, for example, and you end up not getting that job that you wanted. So you need to look at the backup plans as well. If you're looking at that from the undergrad perspective, right, look at the end goal. So like for financial engineering, for example, which is, I'm going to define here, is those that are actually engineering financial derivative products are going to be heavily focused in mathematics. That's what financial engineering is. It's heavy math driven. There is some stats. But in general, right, you need to have a lot of math. So for an undergrad degree, it might make a lot of sense to get like a pure or an applied math undergrad with the expectation that you're going to go get that master's or PhD in the future. And then at that point, you can decide what type of PhD or master's you want to get. But again, you should look at this in the sense of, I want to do this, this, and this. What would be the best degree to do that? Financial engineering, in my opinion, is the best route to that is like a math undergrad and then going into a master's in financial engineering. It's kind of the middle of the road, cheapest route, but it is a little risky because there are a lot of guys in the industry that work on like the research side of derivatives and derivative pricing, and a lot of them will have PhDs in applied math or pure math or even physics or something different like that. But again, you want to get a degree that is heavy in mathematics. Now, that being said here, let's look at these diagrams, Venn diagrams. There's hundreds of these online from all these different industries. I'm going to have two Venn diagrams here, and I'll talk about them a little bit. So for data science and quants and even actuaries and other people that do similar jobs, most of our skill sets are all going to look similar in the sense that they all overlap. So this is the first Venn diagram here. And this is the simplest, purest Venn diagram that basically comes up in my head constantly when I think about degrees. To be a quant, a data scientist, an actuary, like any of these analytical degrees, you're going to need math, statistics, and computer science. Those are the three big ones. Those are the cores. Again, one of the questions I constantly get is, Dimitri, I'm an actuary and I want to move into, risk management or quantitative finance. Or Dimitri, I'm a quant, I have a financial engineering degree and I want to move into data science, or vice versa, right? People want to move into different areas. One of the key takeaways from this is that if you have the core skills in general and they're in a deep enough level, so the rigor that you have for those skills is deep enough, you can really move between different venues before you get going. But a lot of times companies aren't going to hire you if your master's or graduate degree, or in some scenarios, if an undergrad is what's the requirement, they want to see that those degrees match. A lot of times companies don't want to take a risk and say, hey, you have like a financial engineering undergrad and we want to hire you to be a data scientist, but you've only taken one or two classes, right? Companies just don't want to take that risk. So realize that the degree, if it matches with the job you're going for, it makes the application process a lot easier. Now back to these Venn diagrams, the skills are all going to be there. In general though, different jobs are going to require different skills. So looking at quantitative finance as a whole here, again, financial engineering is going to be very math heavy. I work in risk management, which again it's an area inside of quantitative finance. I don't work on the market risk side and I don't work with any derivative products. So the vast majority of my skills and abilities all lie on the statistics side. But again, to do my job, I still have to know math to be able to do the statistics correctly, understand it, and implement it. To do any analytical work, I still have to use computer science. I still have to use programming to implement that mathematics and to implement that statistics into practice and to review data and look at charts and processes. So again, risk management is mainly stats driven as long as you're not working on the derivative sides. There are people in hedge funds, again, that do the programming and implementation of these models. They are going to be heavily computer science focused. So that person is going to be heavy computer science. They're going to need to know at least a little bit of math and a little bit of stats to do that. And then in my opinion, right, that core piece right in the middle, that's where a lot of people strive for, but it is extremely hard to get all three of these at a very, very rigorous level. The level of rigor you have is going to be crucial in defining your career, defining what you enjoy doing, and defining what's going to kind of make you who you are as a person. So looking at these, you probably will end up in one of the areas where there's a double overlap, so like stats and computer science, or computer science and math, or math and stats. But again, having the overlaps is crucial. You need to have multiple fields here to really utilize data science and quantitative finance as a whole. So that's what we're kind of talking about in general. You need to have the overlap. Now, that being said, right, if you go for an undergraduate degree, a lot of times it can make sense to get one of these core degrees. So get a computer science degree, a math degree, a stats degree, depending on what you enjoy and what you want to do. That being said, when you move on to the master's level, I think it makes more sense to get somewhat of a unique specialized degree here. So if you want to go into quantitative finance, a lot of times it makes more sense to get a financial engineering degree because you're going to get more math and more computer science than you would with a pure stats degree. Now, that being said, for degrees, also think about your backup plan. So I talk a lot about, I love statistics. In my mind, I keep thinking statistics might actually be better than financial engineering in many scenarios for many students. The reason being is that most of you are never going to touch a derivative product. You're not going to work in exotic derivative pricing or anything like that. You're not going to be working in hedge funds and proprietary trading. And because of that, most of your job is going to be statistics-based and computer science-based, and most statistics programs will cover both of those very well. Also, you have the backup plan for stats. So if you work in statistics, you can easily work in technology, quantitative finance, a variety of other areas because people are all wanting statisticians to do analytical work. With a financial engineering degree, you're going to be more heavily on the math side. Again, you should be more focused, at least if it's a good program, in the derivative pricing realm. You should be looking at higher end mathematics and then a lot of this implementation again in computer science. So depending what you want to do, you should look at the skills required for that job and then really focus in on what you're doing here. Again, financial engineering might not have as many backups. Yes, I do see financial engineers in risk management, which is mainly stats. Yes, you can find jobs in other areas, but again here, you're very, very specialized. And at the end of the day, it makes it challenging sometimes for banks or tech firms or other people to understand what even financial engineering is. All right, and let me cover data science here quickly because I've talked a lot about financial engineering, risk management, quantitative finance. You'll notice here that math, stats, and computer science are the same skills that make up data science. So no surprise here. If you know the background and the history of data science, it should be no surprise to you that those that are data scientists typically come from a computer science background who are trying to model things, but again, they don't typically have very strong statistical understanding. That's where the field has come from as a whole. Most of the innovations and a lot of it comes from the statistics side. But again, it's coming from the fact that computer scientists and statisticians are getting together and working to figure these things out. So again, data science is going to be those of you that enjoy computer science more so, but you still want to do a lot of analytics. You still like stats and math. From me, I would put a really good data scientist as somebody who's going to fall, again, between the computer science and the stats side, right? We still want to be in that center core where we're awesome at math, stats, and computer science. But at the end of the day, if you're going to really focus on something for data science, you should be looking at things that are computer science and statistics heavy. Okay, and that leads me to the next Venn diagram because most of you are going to be asking the question, Dimitri, hold on. I have a finance degree and I don't see finance on the page. Or I have a data science background. I want to go into data science, but I don't see the business side. Where's the business side? Okay, so this is going to be, I guess, a more complete picture, but I don't want to mislead people in the way that it's done here. You have math, stats, computer science that we just talked about here. We also have the focus. Okay, so this is where it's going to get a little more intricate and a little more detailed. If you want to work, for example, in actuarial sciences, so I'm not an actuary, I'm not an expert on this, but if you want to work in actuarial sciences, you need to go get an actuarial degree. You typically focus on insurance, right? That's what actuaries do. A lot of actuaries want to work in risk management now thinking they're the same skill set. But one of the issues with this is a lot of the degrees you get and a lot of the exams you take for actuarial sciences are written by actuaries who are people who focus on the insurance side, and they've added in things, for example, ERM, enterprise risk management, financial engineering. They've added in topics. But again, your focus is going to be more on your topic of statistics, computer science, and basically your topic here, which is insurance and insurance related things. You're not going to have the same mathematical rigor, for example, as a financial engineer, right? Again, if you work in risk management, so in risk management on the stat side, so financial engineering, risk management, quantitative finance, all that, you're going to be more heavy again on stats and computer science, but your focus, the classes you've taken, the methods you're looking at are going to be more focused around econometrics and financial modeling as a whole. So your focus is financial markets, financial industries. It's not going to be insurance here. So when you're in the beginning of your career and your education, a lot of times you're going to get bucketed or kind of pigeonholed into one group or the other. Now, is it possible to go get a degree in actuarial sciences and then switch over to risk management? Of course. Is it possible to get a risk management degree and go into actuarial sciences? It's possible, right? They have a lot of hurdles and barriers and exams you have to take, but again, you can still do it. There's not like a you must do this to do that. But be careful, do your research, and understand what are the minimum requirements. Because as I mentioned earlier, right, for financial engineering, risk management, quantitative finance, the barrier to entry is a minimum of a master's degree. So you can't go out and get an undergraduate degree and say, hey, I have an engineering undergrad, or I have a computer science undergrad, or a stats undergrad, and I'm smart enough, I want to work in risk management, because they're going to make you get the minimum requirements, which is going to be the master's or the PhD here. Again, actuarial sciences is similar. In most countries, they have similar exams, but you have to take different exams to be certified as an actuary, right? Like I couldn't just run out there and say, hey, I want to be an actuary, and then like go get a job and do actuarial sciences. I would have to educate and train myself on all the materials, the insurance industry, and all of that. And then I would have to actually go and take these exams so that I can work in the industry. Data science is a little bit different here. So data science doesn't have as high of a bar to get in. They accept undergrads, which is awesome in many ways. But at the same time, should you get a master's? That's something to think about, right? It makes you more competitive. You should be covering more topics in greater depth. So for example, when I look for data science masters, and I think about them, the things I look at is going to be how rigorous is this program in statistics and computer science. That's my main focus here. So you'll notice I'm not talking about the business, the topic, the focus area of these. And the reason being is that in most scenarios, I can teach you the focus part on the job fairly quickly because most business concepts, business areas, and problems aren't as complex and do not build on themselves as statistics, math, and computer science do. So it's really complicated when you get into the details, but basically in math, right, you have to learn arithmetic, then you have to learn algebra, then you have to learn calculus, right? And if you want to do stochastic calculus, and if you want to do, I don't know, like topology or something else, all these different fields, linear algebra, for example, they build on other fields. And so it's crucial to have all this base understanding before you build on top of that. With business, a lot of times I can isolate and cut something out to the degree that you will understand it and be able to model it because you have enough information to do it. Now, that being said, you're not going to be an expert. Like, you're not going to be the guy that's going from like a data science or, quantitative finance degree and they're going to like switch sides and run out and be a business expert, right? You still have to train and educate and go get a degree for that. But at the end of the day, I want the takeaway to be here is that it's important to understand the business. So it's important maybe to take a finance class or two or to take a business class or two. But at the end of the day here, quants, so data scientists, financial engineers, quantitative finance experts, even actuaries and all that on here, which is not my expertise again. But all of these different degrees are going to be heavily, heavily focused in math, stats, and computer science being applied to something else. And so while it's important to understand what you're applying it to, right, I don't want to discount that at all. Academically and rigor-wise, it's much, much harder to find people with these STEM, math, stats, and computer science skills. It's much easier to train somebody on the job to do the business-focused area. And remember, you're not going to be an expert in this area, but it's also not the crucial point. So I try to emphasize this when people say, hey, I have a finance degree, I want to do financial engineering, right? You still need that finance knowledge, and that's awesome. You're a little bit ahead of the game there, but you really need that undergrad in math, stats, or computer science to get in and to do that. All right, so to wrap this up here in just general terms, there's no simple, easy route to get to some career or some degree, there are different routes that are going to be better. Big takeaways here, though, are rigor, rigor, rigor. Your program should be highly rigorous in math, stats, or computer science, depending on what you're going into. If you get a degree and you take like 2 stats classes, 2 math classes, 2 computer science classes, and like 2 business classes, you're not going to be very good at any one skill. And I should note here too that when I took my financial engineering program and then transferred into applied economics, it was interesting to see that I spent most of my time doing stats homeworks, focusing on the statistics classes. That was really what interested me and I did the best in out of all of the classes. The math and computer science I didn't do as well in, or the business stuff, because that was not my focus during my master's. I had friends, though, that did really well on the computer science side, and they ended up going into implementation roles where they're actually optimizing algorithms and codes for programming because they were the best at that. I was the best at stats, so I ended up going into risk management, which is mainly stats-driven. I had friends, again, that were very, very good at the mathematics side. They had undergrads in mathematics or engineering or physics, and they went into the derivative realms where they focused solely on doing derivative pricing, again, where math is more heavily utilized. So we all were in similar programs or the same program. Depending what classes we liked, though, really determined where we ended up. Again, I'll just emphasize here for data science. Data science is awesome. It's amazing. It has a lot of different aspects to it, but you have to realize it's really just computer science and statistics put together. So trying to figure out which side you're better at is going to help you decide which job you should go into. So for example, maybe you should be more of like like a warehousing engineer, data engineer, someone that's on the computer science side that wants to focus more on like the hardware and setting up data and systems. Or are you going to be more on the data science / machine learning side, where you understand and you're really good at computer science and you really love statistics, and there's nothing more to it really than different statistical methods invented by some computer scientists and a whole bunch of stats, all invented by statisticians, mathematicians, other people, all kind of merge together into that data science route. So if you want to go into data science, again, data science is very flexible. You can work in tech, finance is hiring now, general businesses, manufacturing, for example. Everyone's trying to get in on this data science, machine learning aspect here. Again, getting a good degree that is rigorous in stats and computer science is going to be crucial. So if you have a program that focuses on like a whole bunch of just business classes, the focus side, so you take like a couple on like the medical industry, like biomedical, and then you have some that are in business and some in finance and some in manufacturing and some in technology, and right, these degrees are going to be too general and too broad. They're realistically like a management degree or someone that can be a manager in these areas, but they're not going to be someone who's a really dedicated, hardcore data scientist, because you just aren't going to have the rigor. So in picking programs, look for rigor. I can't emphasize that enough. Again, make sure it matches up with what you want to do as the end goal in the career. And to wrap this video up here in a final note, please do not ask me which programs you should go to, okay? I know this is hard because a lot of you want to know an opinion or a view on this. I do not like giving opinions on programs for many, many reasons. The main reason is I have never gone to that program. Anybody can create a website, anybody can list class names, anybody can write descriptions of classes and make them sound exciting and fun and very rigorous and detailed or very fluffy and light. But at the end of the day, I don't know because I don't go to those programs. So me advising you on a decision of spending $70,000, $80,000 for a master's, for example, it's not really a good use of my time. It's probably not going to be the best advice you're going to get. So for those of you that do know, I did do a Michigan review program on their program. I actually flew up to the campus. I visited with the professors. I sat in classes. I talked to students. I reviewed all the curriculum. I looked through the textbooks they used. I dug very, very deep to get a lot of detail because I don't want to recommend a program if I don't truly believe in it and don't think it's a good investment for your time and money. So anyways, please don't ask. Look for rigorous courses. Again, stats, math, computer science, those should be your focuses for data science and financial engineering and quantitative finance as a whole. But anyways, thanks for watching. Don't forget to like, share, and subscribe. And as always, until next time.